Okay, welcome to Linux Music One. This week we're going to look at scales, tonality, how do we use different scales in any time, but primarily within Zen Add Sub Effects. So stick with me. Let's get started. Okay, well, here's a string vibrating. We're doing music, not pictures, so the artwork doesn't count. Here's a string vibrating at 110 vibrations a second, 110 hertz. If I exact same string, same tension, everything else, make it half as long, it'll vibrate at 220 hertz. And we've talked many times before, a doubling of frequency is known as an octave. And people have always been able to sense, well, some people, we'll talk about that, that doubling of frequency is they're connected, and neuroscientists, how they take images, wire up electrodes, whatever, they found that that's hardware in your brain. The thalamus in the brain recognizes this principle of octave equivalency. That's what it's called. And it's not just humans, all mammals, even rats show octave equivalency deep in their brain. The thalamus sitting right there on top of the brainstem seems to recognize that these two notes are connected. Now, what's kind of odd is human infants have octave equivalency. Musicians all seem to have it. But starlings don't have it. 4 to 9 year old children don't have it, and lots of non-musicians don't have it. So I'm not gonna, say anything about non-musicians, but you can take it from there. So let's go look at that, because notice that's doubling or halving of the length of the string. And early on, back in Greece, whatever, they discovered that. Wrong pad. There we go. That nice whole fractions seem to result in tones that they found pleasing. So here is a C note, 256 vibrations a second. Count up C, D, E, F, G. F and G are known as the fourth. You can use your fingers for that if you need to. Now notice a G is 384 vibrations a second if I say that it's 3 halves. So if I take a G and start a scale, notice that the C is 512, which is exactly 256 times 2. If I take the fourth, the 341 vibrations a second, count up to their fourth and fifth, notice I'm at 512, and so everything plays really nice. This using the fifth and using the fourth keep things in sequence. In fact, so much so that you might have heard of the cycle of fifths, which is nothing except take a C, find its fifth, take that G, find its fifth, take that D, find its fifth, up and up and up and up and up, and after 12 iterations, it'll be back to a C again, and everything stays in sync. But if we open that up to more fractions, try to make a diatonic scale, notice here's the same frequencies. I just plugged in the holes for the diatonic scale. And here, if you didn't use your fingers, 1, 2, 3, 4th, and 5th. And I start plugging in those frequencies with those fractions, 9/8, 5/4, 5/3, 15/8. Notice that a C, if I look at the D in the C scale and look down here at the D in the F scale, they're off a little bit. 286 doubled is not 569. Same thing here. If I look at the A and run the fifth, then this is off a little bit. And that makes, this is called just intonation, when all the frequencies are exactly nice whole numbers and fractions, and everything kind of vibrates with itself. And just intonation provided a pretty serious problem for musicians, in that they could play a C really well if they tuned their instrument, but they couldn't go to G, it'd be a little bit off whenever they were playing that A note. And if you look down here, if I don't use the fourth and fifth, just pick another note, a C, and then take the 288 and start. Now two notes are out of tune, and it works that way up as they play keys that are a little bit farther apart. More and more and more, the notes are off and they're out of tune. So you can have just intonation real easily, as long as we all agree that we're playing in one given key. We tune the strings, the flutes, the holes, the drums, whatever it be, to that frequency and roll from there, and everything is just exactly perfect. If we go to a chromatic scale, 12 tones in a scale. So you get your C sharp, D, D sharp, E, etc., etc. Put in our same frequencies. Look at our fifth and our fourth. Notice that when I come down here, even in a strongly related key, starting in the G, I've got two tones that are out of tune now. And if I come down here to from C to D, look at that. I've got 1, 2, 3, 4, 5, 6 tones that aren't in tune. And so as music started to move between the medieval and the Renaissance, and musicians, like musicians everywhere, wanted to stretch the boundaries, play with lots of tones, go with chromatic scales. They found more and more of this problem of tuning, and you can see here's the second, here's the third is pretty far off, and thirds were important to musicians as they were getting out of medieval music, because, well, for one thing, they thought that old stuff of the root tone and the fifth was kind of fusty sounding, kind of old sounding. They wanted to push the boundaries, but mostly a major third from this E defines what we think of as a major scale, and throwing in a minor third is what we call a minor scale. And so thirds became very, very important to them as they were trying to sculpt their music, and this whole thing was just not working very well. So let me show you another picture here. And they tried to fix it. If you look closely, this keyboard has lots of keys where they're trying to make up for the fact that things don't play well in one key. So maybe if I'm just playing on this lower set of the keyboards, the white keys and the black keys, first pass through, and if I want to change the key, then I got to move up, and I want to change the key, then I got to be playing on the first and fourth set of keys, and that stuff just was creating a monster. So along comes Bach, and you might have heard of the Well-Tempered Clavier. And what he did was there's two stories. One is that he drove his clavichord tuner crazy by repeatedly hammering on an A flat and trying to make the point with that guy that it didn't work. But what he did was he started fudging on these a little bit, so things weren't quite in tune exactly, but they were all just a little bit out of tune. And he tried to prove that you could play in all 12 keys with a keyboard that was tuned. Now, he wasn't using a piano; they hadn't invented pianos yet, but pipe organs, harpsichords, clavichords, et cetera, et cetera, et cetera. And actually, he did that twice. He did two sets in 24 sets of music in all keys to make sure that people understood that we could play in all keys if we just fudged a little bit. Well, through the 19th century, well-tempered gets closer and closer and closer to what we call equal temperament. And at the start of the 20th century, we only had equal temperament, where every one of these is the exact difference from the one before multiplied. And some musicians would have you believe that our music sounds like crap since then, that was a poor compromise. Just intonation, there's lush harmonies, and the harmonics from the various strings that are playing all combine and make for a very, very much more harmonic piece of music. and that you're just going to have to sacrifice not playing in multiple keys very well. Other people, as you know, we play music frequently now, and this is what's called equal tempered intonation. And well, I like my music, but we'll get more into that. Music theorists have tried for a long time to overcome this, to try to somehow make scales. Sometimes scales with, instead of 12 notes, 7 notes or 19 notes or 24 notes or 31 notes or 53 notes or whatever it would take to try to resolve this issue of equal temperament versus just intonation, so that strings, so that you can play notes that still sound harmonious with each other while still having access to all the keys. So that being said, let's go look at Zen and throw up a different scale or a couple different scales and see what that means to us in trying to experiment with this for ourselves in a synthesizer. Okay, well, here's Zen that we've been playing with all along, and here is the virtual keyboard that comes with it. And if we look at it, here is a diatonic scale, do, re, mi, fa, sol, etc., etc. Here is the chromatic scale starting on C. And hopefully you hear the octave equivalents. You're a musician, not one of those others. And if we want to play with scales here, we come to File, Show Scale Settings, enable microtonal, and notice that we always end at 2 to 1 if we're interested in an octave equivalence, because this would be twice as many. And let's just come in here and put in the fractions we were using just a minute ago. 5/4, 4/3, 3/2 on our diatonic scale, 5/3, 15/8, do, re, mi, fa, sol, la, ti, do. Okay, we got it. I hit retune. Notice down here, 12 notes in an octave. I hit retune. Now it knows I'm back to 7 notes in an octave. I'll close it. And if I just try to play the white ones, notice I don't have octave equivalency, because I've taken out 12, and I have to play those black keys. So the same old way, the C, D, E, F, G, A, B, C. It's not C up here anymore. So, and that's going to be the same thing on a piano roll if we're looking at Seek 24 or anything. By going from 12 keys, 12 notes in a scale to any other number of notes in a scale and trying to map that to a keyboard, we have problems. Not necessarily problems, but you've got to keep it in mind. And so a piano roll that you made and that sounded perfect with 12 notes in that scale, if you were to make a different scale and choose any other number of notes other than 12, then your music's going to be off. And next week we'll explore that some more. We'll start playing around a lot more with different scales that we can load in and try different things. But for now, just be aware as you go through this week, because I know you try things. You don't just watch these. You roll up your sleeves and get into the software. That if you're going from 12 notes to anything else, then your keyboard is not going to map real well, and you're going to have to take that into consideration mentally when you do it. And otherwise, I hope you learned something. I hope I didn't confuse you more, and we'll see you next week. Okay, well, that was it. Apologize for the length, and boy, that was a fast blast through a lot of material. Hope I didn't confuse you more. Here's the versions I'm using. If your stuff doesn't act like my stuff, which and we didn't show you too much of my stuff this time, but next time we're going to get more into playing around with the Zen and the actual scales and setting up new ones and having some more fun. So otherwise, roll up your sleeves. Let's have some fun, huh?